Okay, with these problems we'll finish up the ones that we want to work with in section 5 of chapter 5. And these are logarithms other than base e, and when that's just log of some base a, it's log base a of x, it would be 1 over x times the natural log of a. When we have a function for x, and we'll call that u being a function of x, then that would be 1 over u natural log of a times du dx by the chain rule. Alright, so let's see what we get. Number 49. So here we have log base 3 of x. We're looking for the derivative of that. And so again, that is simply 1 over x times the natural log of 3. Number 51. Now once again we have the log of a quotient. The log of a quotient is the difference of the logs. So we end up with the derivative of log base 2 of x squared minus log base 2 of x minus 1. We can bring the 2 down from the x squared. So we have two different logs of base 2. And so the first one, log base 2 of x, is just 1 over x ln 2. So it's 2 over x ln 2. That's the first one. Then it's going to be minus 1 over x minus 1 ln 2. And times the derivative of x minus 1, which is still 1. So that's all there is going to be for that. Now at this point, possibly we could get a common denominator of x times x minus 1 times the natural log of 2. And so we would have to multiply the first term by x minus 1 over x minus 1. And the second term we'd have to multiply by x over x. So you'd get an x there. And you should see that's 2x minus 2 minus x, so it becomes x minus 2. And nothing cancels there, but it's very clear that that whole expression is going to be 0 when x equals 2, and it will be undefined when x is 0 or when x is 1. So that's number 51. Let's see if we can get to number 53. So I can rewrite the derivative of log base 5 of the quantity x squared minus 1 to the 1/2. I can bring out the 1/2. And remember, we do have a property for the log of a quotient, but we don't have a property for the log of a difference. So that'll just have to stay the way it is. And now we're ready to find the derivative of that. It's going to be 1/2. That's by the constant multiple rule. And then it is 1 over x squared minus 1, which is the u there, times the natural log of 5. Then we'd have to multiply that whole thing by the derivative of x squared minus 1, which is 2x. Those 2's will cancel, and we'll end up with x over x squared minus 1 quantity times natural log of 5. So once again you can see where that will be 0 when x is 0. Where will it be undefined? When x is plus or minus 1. Okay, I'm going to scroll down, see if we can fit in number 55. And here we're looking for the derivative of 10 times log base 4 of t over t. We're going to need to have a quotient rule here. We'll start with low and then d high. The derivative of that top part is going to be 10 times 1 over t natural log of 4. So that's 1 d2, then minus 2 d1. I'm sorry, that's low d high minus high d low. And since the derivative of t is just 1, so we're going to have minus 10 log base 4 of t and all over t squared. Simplifying that first term up a little bit, the t's will cancel there, and that will just be 10 over the natural log of 4. Now for the second term, it's going to be 10, but we can use the change of base to convert that from log base 4 of t to ln t over ln 4. So that would be 10 ln t over ln 4. And that's all over t squared. So if I multiply top and bottom by ln 4 and factored out a 10 from the numerator, I'd get 10 times 1 minus ln t over t squared ln 4. And that will be 0 whenever ln of t is equal to 1, and that happens when t is equal to e. ln of e is equal to 1, and it will be undefined when t is equal to 0. Alright, so that brings us through problem 55. And that's all we really want to do in this section for right now. Alright, so we're just practicing the basic skills of finding derivatives of logs and exponentials, base e and other bases.